You know how it goes, right? You start with this perfectly clean, simple piece of code. But over time, feature after feature gets bolted on, and before you know it, it's a complete mess. Well, today, we're diving into a really powerful design pattern that can stop that from happening. It's called the Proxy Pattern. Let's see how it can help.
Seriously, think about it. Have you ever had a project start out so pure, so focused, only to watch it grow into this tangled beast of responsibilities? You add one little thing, then another, and suddenly, that simple code is anything but. Sound familiar? Well, what if I told you there's a way to add all that extra stuff? I'm talking logging, caching, security checks, without ever touching your core business logic. That's exactly what we're going to dig into today. All right, to really wrap our heads around this, let's start with a classic coding headache. I'm pretty sure most of you have run into this one before. The task seems so simple, right? All you need is a little object that can go to a URL, grab some data, and bring it back. Easy peasy. But then, reality hits. That core data fetching logic, that's just the start. Pretty soon, you realize you need to handle network errors. Then, your boss wants logging, so you can monitor what's happening. Oh, and of course, it needs to be faster, so you've got to add caching. And boom. Just like that, your beautiful, simple data fetching class is now a monster. Its main job is completely tangled up with all these other side jobs. And now, the code is a nightmare to read, a pain to test, and almost impossible to maintain. So, how do we fix this mess? Well, say hello to the Proxy Pattern. It offers a brilliantly elegant solution by introducing what is essentially a placeholder.
Okay, so the official definition tells us a proxy is a stand-in, a surrogate for another object. In plain English, the client thinks it's talking to the real object, but it's actually talking to the proxy instead.
Think of it like a security guard in an office building. You don't just waltz up to the CEO's office, right? No, you go to the front desk, that's our proxy. The guard handles your request, maybe checks your ID, logs your visit, and then they connect you to the person you're there to see. The proxy object does that exact same thing for your code.
Now, here's the absolute magic trick that makes this whole thing work, and it's a key idea from the legendary Gang of Four book on design patterns. The proxy has to look and act exactly like the real object. It has to be perfectly substitutable. This means your client code doesn't have to change one bit. It just keeps talking to the same interface, completely clueless about the complex stuff happening behind the curtain. Okay, theory is great, but let's see this thing in action. We're going to go back to our API client and refactor it, but this time, we'll use the proxy pattern.
This is where you see the real beauty of it. First, we strip our fetchURL class back down to its one job, just fetching data. That's it. Then we create a proxy. Let's call it xFetchURL, and it holds on to our core object. This proxy is in charge of handling exceptions and logging before passing the request along. But wait, there's more. We can chain these things. We can wrap that proxy in another one, say cacheFetchURL, which adds caching to the whole operation.
And the best part? From the client's point of view, nothing has changed. It makes a single call to a single object. It has no idea it's actually talking to this awesome chain of proxies where each one is cleanly adding its own piece of functionality. So we've seen the how, but let's talk about the why. Why is this such a game-changing technique? Let's zoom out and look at the huge benefits for our software design. First up, loose coupling. Our core data fetching logic has no idea that logging or caching even exists. It's totally decoupled. Second, this makes testing an absolute dream. You can write tiny, focused unit tests for your core logic and then separate tests for each of your proxy layers. And maybe the biggest win of all, it sets you up for the future. Need to add authentication? Just whip up a new authentication proxy and slot it in. You don't have to touch any of your existing working code. And you know, this isn't some newfangled idea. It connects right back to that original wisdom from the Gang of Four. They argued that truly good design isn't just about what you need now. It's about anticipating change. The proxy pattern is a perfect example of that principle in action. You're building a system that's designed to evolve. Okay, so where does the proxy pattern fit into the whole universe of design patterns? And maybe more importantly, is it always the right move? So, design patterns usually get sorted into three big buckets. The proxy pattern lives in the structural category. That just means its main job is to help us organize our classes and objects into bigger, more flexible structures. It hangs out with other well-known patterns like adapter and decorator. Now we get to the million-dollar question. because just like any powerful tool, you can definitely misuse it. So when should you not reach for a proxy?
Well, you probably want to steer clear of it for really simple things, where it's just adding an extra layer for no reason. If you don't actually need fancy features like access control or lazy loading, and if creating the real object right away is totally fine, then a proxy might just be overkill. Remember, a pattern is only useful when you actually need the flexibility it gives you.
And this brings us to a really fascinating, kind of controversial point, especially for anyone working in a dynamic language like Python. The argument goes that the language's own built-in features, things like first-class functions or monkey patching, can often get you the same result, but with way less formal boilerplate code than a classic design pattern.
Which leaves us right here with this final question. Is the proxy pattern an essential, powerful tool for building clean, maintainable systems, or is it sometimes an over-engineered solution, especially in our world of modern dynamic languages? Well, the answer, like with so many things in software, is that it really, really depends on your context.